looks like it. Okay, great. So the stream is live. Now we can go and start doing some development. So hello everyone, whoever is planning to join. Let's see how it's going on. So today is Tuesday, 2nd of June. It's 8 p.m. Amsterdam time, and today I'm gonna start continue working on JavaScript library. I was working yesterday on, and this is my second stream on Twitch, so let's see how it goes. Let's start with switching, of course, to the editor. So let's clear the output. Let's see what we've finished on yesterday. So yesterday we wrote a couple of tests, and we still have 2 tests not being implemented, right? So we still have these 2 tests not yet being implemented here, and we have a bunch of stuff that will probably expand today. So what can we start with? We can start with this little test that tells us it should ignore loaders that do not have cookie marker. So let's recap a little bit what kind of library it is. This is a library in order to cache and guard executing any HTTP request to the backend of the front-end application. That would allow us to just tell, hey, let's say this shopping cart block, or this comparison of products block, or this customer account block, that those blocks should only load data from a server if we have specific cookies set, and it needs to cache the result of those HTTP calls in the browser, and only if those relevant cookies change, we have to do another HTTP call to a server in order to check what is the current contents of the shopping cart, or what is the current contents of the customer account block. So let's see how it goes on. Let's start with this test. Let's right away just execute it, right? Let's see. It passes probably, so let's just write some test that false to be, let's say, true. So this one definitely should fail. And it fails as expected. Okay. So it's first of all needs to be an async function, not the synchronous one, because we're gonna test this loader itself. So what it tells us that it should ignore loaders that do not have a cookie marker. Let's see. So right now we have something like this one. So what we're gonna do, we're just gonna add a bunch of loaders, right? And I'm just gonna add to the loaders those various data resolver load calls like shopping cart, customer account, wish list, and as well we're gonna take compare products too. So customer account, shopping cart, wish list, and also compare products. So this is going to be our test setup. What it tells us here: contains a function but never queried. Yeah, because I didn't query it anywhere. And then I'm gonna execute await promise all, and then I'll add these loaders. So I wait till all of these loaders gonna complete its execution. So there is some value available over there, right? And after that one is done, we can access the data from our fake loader, the section of loaded sections, right? So we can take here loaded sections, and then it should equal to only 2 blocks that actually have cookies. So let's see which one of them have cookies set. So it's cart and the wish list. So we need only to have shopping cart and wish list to be loaded through a section, right? So let's see how it goes. Oh, we received an anonymous function, yeah, because I didn't specify it correctly. So let's see. It tells us that, yeah, it works pretty well, right? So that's not what I expected. I expected it actually to fail, because I wanted also to change a little bit the way how these operations are executed. So the loaded sections, I wanted to have every single loader actually flashing. So I want to make sure that, let's say, the loaded sections here get sliced from 0 till 0, actually splice. And do it count is loaded sections length. So I just want to clean it up, so I don't want to have anything inside of this function. And here then we'll just return back this promise resolve with some values. Let's see. Is it gonna fail finally now? Yeah, so now it fails because right now every single load actually triggers a load in the server, and I want to combine all those loads together. So I modified a little bit my fake loader in order to account for that. And then over here, now I need to find a way in order to combine all the load operations together. So I don't want to load the data for each of the blocks I don't want to load the data for each of the blocks separately. Right, I want to patch it together. So what we can do here, we can then hey, hello there, we will open the economy. So here we are gonna go and start doing stuff. So what we're gonna modify here, we probably want to create some kind of a lazy loaded list of operations. So we can, for instance, create here a const like data to load, let's say, right? Like that. And it's just gonna be a set of promise resolvers, or probably we can even just make it an assignable variable, because we're gonna change the value at the runtime for that variable. So this should be fine then. And here we're gonna create this data to load. What we're gonna put here? Push, right? So push, and then we'll create a new promise, and this new promise is gonna receive as an argument resolver, right? However, probably we'll have to handle rejection as well, but we'll focus on that one later. So here's our resolver, and then we're gonna take a look at this resolver. So we have resolve, then we have this loader, so what we're gonna do here, data to load, we push this promise. Oh, basically this is actually not the right thing. Actually wanted to have something like that, and here inside of our promise creation, we're just gonna have this data to load, and we're gonna also put here a section as well. What we can even do, probably better, yeah, but it's this one I think is fine. So just resolve and section, or for instance we can just put section first and then our resolver itself. So here's our promise. Okay, so that's should be fine, and this probably should fail couple of tests. Yeah, so tests are actually failing now because some of the promises are never get resolved. So this is expected because we broke the functionality. So now we can also set up, let's say, interval, or better to do it for the timeout. Probably better to do it for the timeout, and we'll create here a function and we'll call it schedule load, and another one will be execute loader. Okay, so this is it. And probably I can change it to const, because I can just unshift from the data to load. So hey there, Rocon's economy. Yeah, thanks for being a fan of my Magento 2 work. Nice to hear that. So what I'm planning to do, I'm actually going to use this library in Magento 2. So this is going to be used in my customer section load extension for Magento 2. However, I write it as a standalone JavaScript library because it's much more easier to test it as a standalone library, and it's better to do small pieces and then bundle them together and just test that all the pieces working together, than trying to create a Frankenstein extension that you don't have automated tests for. So this is basically the purpose of this library. Okay, so here we have return new promise, resolve, data load. So this is where we finished, and now we have two functions to implement. We have schedule load and execute loader. So what can we do with a schedule load? With the schedule load, we'll just probably, we can just pass this stuff in, right? So we can just pass in here into this function, we can pass section and resolve, right? So these two things, and we can just execute here. So schedule load, section and resolve. Here it is, and data to load push like that, and then we're gonna set a timeout that will execute a loader itself. Let's say we don't care, so we just set timeout. So we just want to execute it outside of our main thread. So we just schedule it on the next event loop tick in the browser. So in such a way, our loader will be scheduled in the browser to be executed after the rest of the loaders try to load the data for themselves. Or we can even make it probably better. How much milliseconds we can put here? Maybe like 20 will be more than enough to execute a loader after 20 milliseconds. It doesn't matter much. Okay, so here we have timeout being executed, because probably we also don't want to postpone the page loading process. We just want to proceed as we go. Here we have execute loader. So what we're gonna do with execute loader? So here, let's see, what can we schedule here? So data to load, we're gonna shift. So first of all, while we have some data, okay, what is this? It's while item. Can we do something like that, or not really? let's say while data to load. Okay, so if data to load length, then we're just gonna return back the entries. So we probably wanna execute something like reducer or something else. So what do we need for a loader? We'll need to add a resolver somehow after the stuff gets loaded from a server, right? So we need to make sure that it processes both of the cases, but doesn't matter at this point. At this point, it doesn't matter much. So how are we gonna go about it? So how to make this data load work? So this data load is gonna take we're gonna just splice it, right? So what splice does, removes elements from an array, and if necessary inserts new elements in their place, returning the deleted elements. Oh, so it's actually exactly what I want to do, right? So then I can do splice for data to load length. Then I'm gonna map, and inside of a map, first one is gonna be a section, then other one is gonna be a resolve, and here we are. So basically we can just return early here, and otherwise we're just gonna splice. Then we're gonna change something here, right? So we have this section, we have resolver, we have to create const sections, right? And into the sections we're gonna push a section itself, and after that one is done as well, we need to create another one. Let's call it promise resolvers, or callbacks, better call it callbacks, yeah. So then into the callbacks we're gonna push our resolve function, and this resolve function is gonna do a bunch of stuff here. So let's see, here we have sections push, section, callbacks push, resolve. I think that's kind of enough. And then we're gonna call loader, and this loader is gonna receive sections as an argument, and then we're gonna expect that after this one is done, after this stuff by the loader is done, then we're gonna execute some of our functionality, and our functionality is just gonna be taking the callbacks and doing an invocation on each of the callbacks. Probably it's not a map, it's even not a reduce. It's just a regular for each. On callbacks, resolve. And here we are just gonna call resolve without anything. Just see what's gonna happen. Okay, resolve is not a function. Because for each calls the data on each one of the callbacks. Okay, why resolve is not a function? Oh, I see. My bad. So here it is. It should be something like that. Okay, so now our test is passing. Okay, so this one works. So what we're gonna do now, now we're gonna have a very similar test case, but this time, so that one we just were checking which sections were loaded, but now what we're gonna do, yeah, you know what, I can, by taking some time here, I can actually go on and optimize a little bit this piece of code. I just want to make it a little bit more readable, because I don't want to repeat myself with calling push, because right, we define all the data ourselves. We don't need to call push. Yeah, have push all the way here, and basically we even don't need a variable in this case. We can just tell, hey, promises all, await, and basically our test execution is actually looks much more decent, right? So now we can do another thing. We can expect that awaiting for this operation. Yeah, I need to put a sync in front here. It should equal to the value from customer account. So the customer account is never going to be loaded. So the customer account should always be name anonymous. Right, this is it. And the second one is shopping cart. So the shopping cart is going to be returned from a server, and we were creating some kind of data. Oh, sorry, the customer should be not anonymous but guest. Yeah, guest. Okay. Then another one related to customer to shopping cart. So the one that is related to the shopping cart should return us the data like this, right? And here we are. let's just inline it, because right now we actually compare just multiple items. We don't care if the JSON structure is on one line or not. Then we were checking also probably for wish list, right? Which the next one was, yeah, the next one was wish list. And here we are. And the compare products, as I remember, it was something like product IDs. So here we are. And this is what I expected to return me. And I expect this test to fail. And this is actually what happened, because instead of the data that I expected to receive from a backend, right, I received 2 times undefined. So you can see here in a test result, our test failure, you can see expected one, so I expected to receive this object. However, I received both times, I received undefined, because we didn't implement that part yet in a data resolver. So here we have our callbacks, and what I didn't do here, when I receive these sections, right? So here, for instance, I have a data, and here I just want to resolve data with something on it. So what do I do here actually? Basically, do I need to do a map like this? I think I don't really. Yeah, this piece of code, but we'll refactor it later. Let's focus on making it actually working. So first of all, I need to pass in something here. So I need to pass in the section itself. So we'll put it like this. We'll make it section resolve, and here we're gonna specify it in such a way, and here we're gonna resolve it with the data received from a backend with a section being passed in here. So let's see, does it work? It actually doesn't, because it tells us that resolve is not a function. Very nice of it to notify us about it, because the callbacks look fine, but my code here doesn't look good. Okay, as always, the problem is always in your own code. So here, should return data from loader for all requested placeholder sections. Something doesn't look right. Probably because our loader doesn't return any data. Let's see. Maybe our fake loader doesn't actually return any data. Is it possible? Could be. Always could be, right? No, it actually returns data. So what's the problem then? Oh, I see then. I see what's the problem. So our loader itself is a little bit incorrect, right? Because we expect only one section being returned from the map. Yeah, so this is not a valid way to do it. I shouldn't use here a map, I should actually use here a reducer. So it should be a reduce. Yeah, sections are fine. And here we'll need to pass a second object, so let's format it a little bit to see what was the problem here. So here's the second argument. I pass an initial value for a reducer, and then I need to pass this value here as an argument into the reducer. So result, and this result section is gonna equal to this expression. All right. And then I'm just gonna return back a result of the reducer itself. So in the end, now it should be a valid object, right? Yeah, and now all our tests passing. So now it all works as expected, and we have everything green. So now we can go on and final refactor this mess here. So there's plenty of things to take a look at. Probably we can replace this variable with a function itself, right? So we can see that it's a good chance to actually create a function for that, and probably probably this function can be out of this scope, but I'm not 100% sure. Can we actually move all this stuff up here, like sections and data to load? Like, can we just define it here? Will it work? Oh, probably not a good idea. So sections, data, schedule load works good. So this is internal functions, it's visible only here. However, I don't like to have such large functions here, right? So what can we do actually? We can probably move this function outside, and this function so these things like sections and other stuff are actually gonna be outside here. So this is gonna be a private function of the module, and then here execute loader will receive a loader as an argument. So here we have loader, and here we have just a simple anonymous function. Hey, the most newbie, how are you doing? So let's continue. So here we have a schedule load still being here because we need to have it in the same scope as this variable that is passed as an argument. However, the rest of the things we moved out. So what I wanted to do, I wanted to refactor this mess. Let's see if the tests are still green. So tests are still green. That's good. So we can refactor this mess. So first of all, like, it doesn't make sense to assign variables like this. We can just specify const callbacks as a result of this map, and this map is just gonna be nothing, like it's just gonna be something like that. So from callbacks itself, here's where we're gonna actually use the map, and we're gonna take the first argument as a section, and we're just gonna return back section as a mapped value. So we send an argument into a loader in such a way, and then we actually work through all the callbacks. So we kind of refactored this piece of code, and yeah, now in my opinion it looks better, like smaller, more concise. So let's see what else can we refactor here. This one I don't like either. So our required cookies satisfied, like this doesn't make sense. What we have here we have required cookies being received as an argument. So we probably can somehow to refactor this function and move it into the global scope. And we can call it is required cookie set. Okay. And here it looks definitely much better, and then we can just inline this one here, Control Alt N, and we just inline the call here. Okay, so now it looks even better. So now this method is under the threshold of being concise and understandable, so looks good. I'm so far happy with it. So, and so far all of the tests are passing, so we can go back into the test cases, right? And we can go on and start implementing the other test scenarios. So this one was actually a very simple one. We just we're checking for value availability, if it's there or not. Now we actually have to implement the cached behavior, and this is where all the fun starts, right? So what do we have here? Here we have probably as well the loader and loaded section doesn't really matter. Like, I think it shouldn't matter, right? So or it is, probably it is, it matters. But what we're gonna do here, we're gonna just use the good old tradition of copy pasting stuff. Right, so definitely now, as we are going into more test cases, I want to refactor this piece of code into a known function, right? So let's do it like that then. Let's extract it as a function in global scope, and we'll call it create or setup data resolver. Okay, good. And as an argument, I don't think it needs to receive anything of this as an argument, so we're just gonna have a const here probably. Yeah, so here we can put it as a const, and here it's also going to be a const, and then we're gonna return back a loader, loaded sections, and data resolver. And this is all the things that needs to be set up. And then here we can just specify it like this, and then we can basically just reuse this piece of code in another test case as well. So now we have kind of a fixture being encapsulated into this function. So this one is set. Now we can just copy it over and paste it over here. So here, before each of the test cases, we're just gonna create a new loader, new loaded sections, and new data resolver. The storages are already cleared up in the top part of the page, right? So this should be fine. Probably what we can even do, we can even move these variables one scope higher. And what we can even do, like if we are moving it one step higher, we don't need to specify here property definition, and we don't need to return anything from this function, right? Because it's just gonna be working out of the box, and then we just gonna specify here before each thing. We can even simplify it even more, like we can just call it something like this. And we can call it, instead of setup data resolver, let's rename it to setup e-commerce data resolver. Okay, so sounds fun. Good. Here we are. And let's see. Do our previous tests still run? Yes, they are still running, and that's good. That's good, good, good. So now we can go on and write the rest of the tests. So here we have our cached behavior to-do list. So let's see what kind of first test that we should implement here. should return value from cache if all cookie markers are the same, right? Okay, good. So and what it does for us then, so should return value from cache if all cookie markers are the same. Okay, so basically what it's doing here, it's actually preventing us from reusing this data, so we probably have to change it a little bit, because I want to have a separate test data for each of them. So here we can call it with default. However, better probably still to wrap it around into a closure like that, because I want to make sure that there is no unexpected arguments are passed into this function. And here I want to specify cookie values, and I want to specify section backend responses, and those two variables are completely optional. So our cookie values, first of all, is going to be either cookie values, or if those are not set, we're gonna set them to this data. And for shopping cart and other dynamic data returned from a server, we're also gonna set up very similar functionality. So if it's set, then we do one thing. If it's not set, we do completely different stuff. So here we are. We have sections, backend responses. We have shopping cart, customer account, and wish list being predefined. So if needed, I would be able to call it with customer values in the future. So now I can even make it more better here in the definition. So here we are. So let's see if our tests are still passing. So the tests are still passing, and now I can go on and actually write the test case itself. And here, should return value from cache if all cookie markers are the same. So what I'm gonna do here, I'm gonna specify different cookie values. So the cookie values are gonna be the cart is, let's say, 1, 2, 3, and wish list, let's say, is 5, 6, 7. So those are values that we're gonna use as the markers. Now, what's important, I think, to do is to first of all, we probably even don't need to do anything here, but yeah, it's probably the only way to achieve it like that. So we'll call our data resolver, and we again will use this trick with promise all, and we're gonna pass here an array of various loaders, we want to make sure that something is provided correctly there. And what's important here as well, so here we have it should be something like that, formatted like that, and here for shopping cart we're gonna return back let's say items cached item. So this is what I expect as a result to be cached on the first call, and in the wish list we're gonna have something similar. It's gonna be liked items also cached item. So this is gonna be a result of the first call, and we're gonna definitely do load to shopping cart, and we're gonna do load to wish list. And after that we also, here we're gonna await, and we need to mark our test as a sync. And now after we've done that, we can call another await. However, this time we're gonna set up our e-commerce data resolver with different cookie values. So we're gonna set it up. Actually we're gonna set it up again, but this time with some default data, or for the sake of test being more verbose, we actually will provide some data that should never be returned from the backend. So we'll specify here something like non-cached item, right? So this is going to be a non-cached item as well. And here our promise expects, so here we will expect that result of the promise resolution gonna be equal to items. The first item is cached item, and here is gonna be liked items, and it's gonna be cached item. So this is gonna be our expectation, and we're gonna do both of the loads here. So let's see if it works. Okay, so we see that stuff doesn't look like expected. Okay. Set up e-commerce data resolver. Yeah, this is actually weird, because I didn't expect to receive this one even, because I already called this method here. So this is a little bit weird that we have a shared state. This is kind of interesting then. Let's, oh, sorry. Sorry for your ears. My microphone just fell off. So sorry for that. Let me adjust it a little bit better. So let's see. Let's put actually a breakpoint and see what is the execution flow. Like, does it really call it the second time? So let's see. Yeah, it was a bad idea. Just a moment. Let's stop the execution and let's only debug the cached behavior so it doesn't test the rest of the method. Right, so let's see. Can we evaluate an expression here? Oh yeah, here it is. Okay, so let's go further on. Yeah. And here let's run data resolver in a console. Let's see what the loader looks like. So the data looks like that. Cached item and cached item. Yeah, so the scope looks fine. I don't know why it's having so much issues with it. Or is it gonna be fine if you execute it separately? Okay. So here's some fun with JavaScript, right? It has some side effects here. So why does it have a side effect? Probably because we have stuff being set up over there and over here, and everything just collides together, so it's a little bit complicated, I think. Let's see. This data resolver somehow gets changed. Probably I have to go back into the previous case and just return back loader loaded sections and the data resolver, because probably just somehow doesn't like a global state, and we better to have a local state here. And here we're just gonna assign this stuff like that. And here's a similar thing. Okay. Okay, so I need to define variables here as well. So let's see. Here we are. Let's see if our test runs. It doesn't, because I forget a parenthesis somewhere, right? Let's see. Where is the missing parenthesis? Somewhere here. Oh yeah. Before each, it was in a before each. Okay. That's fixable. Does it run now? Loader is not defined. Yeah. Let's see why it's not defined. Oh, sure, it's kind of not defined because we didn't define it there. And probably also don't need to return it back. So the loader is purely our local variable, and here as well the const data resolver. So what needs to be leaked into the test is only loaded sections and the data resolver itself. So here's the same thing. And here's the same thing. So loaded sections, data resolver. Let's see if our test run. Okay, our test run. However, the last one fails because I don't have additional variables there, and shouldn't have, right? So here we are. Let's say now it's again completely wrong. So what can I do here? I can somehow solve this problem, right? So first of all, like, yeah, loaded sections and data loader, data resolver, sorry. And here, when I reset the data resolver, I also want to reassign it. So I want to create something like that. I just want to set it up like that. So I reassign the variable so I can access it again in a test, right? And now what I receive again the wrong freaking result. And why I do receive this kind of weird result? Is this variable is not set? Wait a moment. Here I set one and the second one as well. So what's the problem? What's the freaking problem? Why it doesn't return me the second one? Why it returns me the cached one? Is it a problem within implementation itself? Does it have some side effects itself? Let's see. Let's see our data resolver. probably know what's the problem, because this schedule load should be probably an anonymous function. Otherwise, yeah, it gets defined only once, and then it captures the state of the original loader. I think that's the problem, right? No, that's apparently is not a problem. Okay. So let's see what it looks like. And let's run all the tests in a debug mode. So the first one is hit. The second one is hit. Shopping cart wishlist, shopping cart wishlist. And here it should be which test case. Okay, so finally we are in the right test case in the debugger. And here our loader should have the proper data in it, right? And it actually has. What an interesting thing, right? What an interesting thing. I probably see what's the problem. So I introduced an unintentional side effect, right? So I introduced an unintentional side effect. Because I created multiple loaders, and this set timeout, it actually happens asynchronously outside of our main test, so it unintentionally executes 2 times a loader. So it executes not the ones that we expect, it executes the first one because it was scheduled prior. So what can we do here then? Let's first of all do maybe 5 milliseconds. That's one thing that can help us, but we also need somehow in a loader we need to clear the previously set timers, right? So we need to add const timers, and here in timers we need to push a timer right. So we create a new timer registry, and then as soon as the first loader catches up with the data to load array, over here we just need to execute something like timers for each, probably, or no, wait a moment, here we even can do something like that. We can do const, and then we gonna specify that actually we don't want to do const, we're just gonna splice. We're splicing all the way timers lengths, and then we're gonna reduce each, or probably even map. It doesn't matter because we even don't receive it back. So it's gonna be timer ID, and here we're just gonna clear timeout timer ID. So this one actually should help us out to cancel all the pending timers, to not execute them. Right, okay, so now as you see, it actually solved our problem. So now only one timer is actually executed. So it clears up timers, so it should be pretty okay. So it's good. And the good thing, it even doesn't complain about non-existing timer IDs, so looks like fine. Looks quite fine. Okay, that's good. And here we finally need to implement some kind of a caching logic, right? So we'll need to set our storage, right? For this one, I'll probably gonna create some kind of a small abstraction, right? So I want to make sure that, all right, on the first call, it's never get viewed. So I want to create a new function. I'll call it storage. And let's create some value for it as well, like prefix or whatever. So the prefix is going to be something, and then we also going to specify here, let's say, a cache key, or for instance section. So it's going to be our section that we're going to cache. Then it's going to be required cookies, right? So here we are. Okay, so we have our storage. It's gonna receive required cookies, and probably here as well we're gonna have a read cookie method also passed in here as a parameter, and we'll call it actually cache storage, so it looks much better. Good. Here then we're gonna just use prefix and other stuff. So this is actually a good chance to create a new component, because the cache storage looks already quite complicated, and as I'm gonna create this one, there's gonna be a lot of edge cases not covered by simple implementation over here. So what I'm gonna do here, I'm gonna create a new file here, and I'm gonna call it cache storage. Oh boy, I need to rename it. Cache storage.js. Good. And now I can create here another file called cache storage.spec.js, and the cache storage is actually gonna export me a function, something like that, right? So it's just gonna export default function and I'm not sure, do I need to create a cache storage for each of the sections, or can I somehow just decouple something related to the prefix? So let's say probably it should be much more better organized, and probably even we will pass this cache storage as an argument to our the data resolver. It's the data resolver, honestly, but yeah, it doesn't matter much. Okay, so this is getting interesting. Oh, I see we have quite a lot of viewers here, so there is at least 5 people watching, so thanks for joining. Hello chat. So what we're gonna do now, we're gonna actually write tests, right? So well, what else can we do? First of all, it's gonna be a describe. So this is gonna be our behaviors. Here we probably want to specify first of all behavior of cache storage isolation, right? Okay, that's good enough. So what I mean by cache storage isolation, I just want to make sure that if I create 2 instances of cache storage with different prefixes, the values in those storages are not shared between each other. So this is probably should be very easy to write tests for. Oh boy, I need to have a second monitor, so then I can have a chat in one window and have a code base being open full screen, then it will be much more easier and even better dimensions. I really need to buy myself a second monitor. I have actually a second monitor here. It's Apple Thunderbolt display, but unfortunately it's not working on current Ryzen CPUs because unfortunately there is some issues with motherboards not supporting Thunderbolt, so it just stands here black without any signal on it, just holding my webcam. Okay, so let's go and create a test plan. So the test plan, the first one is gonna be like, probably we're not gonna call it cache storage isolation, but we're gonna call it cache, let's say default storage options, let's say like that. And then with default storage options, should store values between instantiations. So for instance, I create one storage, then I create another one, and I store value in one storage, and then I store in another one. They both have the same prefix, so in that it just returns me back the value. Okay, should store values between instantiations, so that's okay. This is one to do. Another one should validate. Actually, what it's gonna do, it should not validate. Should invalidate cache retrieval on changed cookie markers. That's one thing, and then let's say another one also gonna be here, should allow storing sections with own set of unique cookie markers. Okay, that sounds right. So that's probably everything what we need to implement right now, because we will actually switch between both libraries. And based on these test cases, our factory, oh my goodness, I put it all in there. I actually messed this up a little bit, so I switched it around, so it should be a little bit different. So here we have prefix. What can we do with this one? So it's gonna probably have prefix by default. We don't care about anything else right now. What it should do, basically, it should return us an object that's gonna have a method like store value, so it should be, or let's say save. Here it should receive section as an argument. Then it's going to be required cookies. Or for instance, probably not required cookies. Let's make it just simple. Let's abstract it away. And let's just call it current cookies or just cookies. Or let's call it markers. Our cache storage doesn't care about what it is. It's going to be section, and then here going to be data, and then we're going to have markers, right? Then it's going to have a load with markers. So when we load the section, we provide markers as an argument in order for our cache storage to validate if the current set of markers are actually the same as the one that was provided before. So let's take a look at our test case itself. So it should store values between instantiations. Work great. It should allow storing sections with own set of unique cookie markers. Work great too. It should invalidate cache retrieval on changed cookie markers. Works great too. Okay, so let's import cache storage from cache storage. Okay, that's good. Now here we have a prefix. That's more or less okay. Here our before each test, we're actually gonna clear up our cache storage just to make sure that there is no side effects. Local storage clear, and Windows session storage clear too. So seems like working solution. Okay, so here we are. We have cached item, non-cached item. Yeah, that's one still failing because actually we're not testing the right thing. We need to test this file. So now it tells us that there's 3 ignored tests. Yeah, because we didn't write them. Here we have a bunch of stuff that we can test. So let's test it. And here we are, writing the test, the first test. For this one, this is not going to be a synchronous test because the storages in a browser are synchronous, so you can't asynchronously access a value. It's just the memory of the browser that is accessed usually. So it should store values between instantiations. What we can do here, we can just create our cache storage. Const storage cache 1 let's say, and here we're gonna have const storage, and we're gonna call it cache storage, cache 1, 2 probably. So we're gonna have storage 1 and storage 2. Does it make sense like that, or maybe I'm going too far? Okay, let's put it this way. Let's then create it here, something like let master storage be equal this one, and let slave storage be equal also the same thing. So we have two storages. The one is going to be used for writing, or better not to call it master and slave, but to call it write and read. So it's even better. And then yeah, this is and here it's gonna be before each, and here we are, before each, write storage equals this one, and read storage equals this one as well. Okay, that's good. So how is it going on? Looks fine. So here we have write storage, read storage, where we can go from here. So we can go from here and just write a test, right? So should store values between instantiations or between instances. So this should be better. Then the write storage save, right? That's what was a method. Is it correct? Yes, save. And we'll call it section 1, the set of markers. So, oh yeah, first it goes data. So the data is gonna be test data, and the markers are gonna be marker 1 equals 1, let's say, like that. Okay, that's good. Here, now what we're gonna do, we're just gonna run it to make sure that it's still not complete, because when the test is green, it means we didn't write it yet. So now we have to put an expect on read storage, load section 1, and then it's gonna be marker 1 equals 1, right? So we expect that the data loaded should be equal to test data. Actually, why do I put the word test in it? in a quote there. It doesn't make sense. We are working with JavaScript, not with some other language that doesn't understand object notation. Okay, so here we are, and basically now we have finally a failing test that we can go on and implement. So we can create a very simple test case, right? So we go over here and we'll set that our browser storage equals window, probably local storage first, or window session storage in case of local storage is not available, because I know on some browsers local storage is not available, so we're just gonna put a logic like that. So this is our browser storage we're gonna use. Let's see if it's still failing. Yeah, the test is still failing. And then we're gonna just implement it. So browser storage, set item, we'll set an item section, and we put some JSON stringify of the data, and that's all. That's good. And here what we will do, we'll just implement it very simple. We're not gonna verify anything. We put it a lot of arguments over there because we know it's gonna happen like that, but for now we just care about the implementation. So now we see right that received value doesn't equal expected object. So now I just need to return back JSON parse of the browser storage. Let's see, does it work now? Yeah, now our test is green and we don't need to implement anything else. So we need to drive our implementation by tests. So I think this test case is a little bit vague in name, so I need to probably split it up. So basically probably I should first implement this one, and then we will decide what we're gonna do with that test case. So let's go and let's implement it. So write storage, save section 1, and then test data 2, and yeah, it doesn't matter to put it in quotes at all because it's all JavaScript. So marker 2 will equal to 1, and now we expect that read storage load of the section 1, and then test, then marker 2. In this case, let's say gonna change the value to 2. So we expect the cache storage to return us back actually undefined. So we expect that it's not going to return us any value, and we know that undefined is not part of the JSON standard, because I think even null value is possible to specify in JSON. So undefined is the only way how we can actually really compare in JavaScript that the data is really not there. So here we are, our test is failing. Let's see if we can actually go on and change our cache storage logic here. So here we have markers. So right now it means that I also need to store for my storage, let's say set item section, again JSON stringify markers, and then here I need to retrieve this set of markers. So I'll just specify like, yeah, let me create right away a function for it. Markers, or let's call it metadata key. So it's gonna receive section as an argument, and it will return back section plus meta. Okay, and here the meta key is gonna contain the JSON data for markers, specified like that. Okay, so this sounds good. So here's our metadata against which we're gonna validate that everything is set correctly. And here we go with loading the stuff. So here we're gonna get this metadata itself, const metadata and here we're just gonna say that this metadata let's say if metadata doesn't equal to JSON stringify metadata. Oh yeah, it should be stored metadata because otherwise the variables are just the same. Yeah, so stored metadata. You know, yeah, we cannot use stringify here, unfortunately. So compelling, but can't use because I already stored metadata a little bit differently. So I need to parse a JSON structure, and then I need to take this stored metadata and take a look at markers. And if markers are not equal to markers, then we'll return back undefined. Is it gonna fix our test now? No, it's not working because now our first test failing because this comparison doesn't work with objects. So what we'll have to do then is take a look at the JavaScript manual. This is the first time I'm opening browser on this stream, so let's say JavaScript how to compare object properties natively. I don't want to write on mappers. Okay, so we'll have to use a function like this, so we need to access on property names from one object and from another one. Yeah. So let's just write a simple function or objects. Yeah. Compare markers. So, or for instance, yeah, just compare marker values A and B, or left and right. It's better, more descriptive. So we're gonna take a look at object keys of left, and we're gonna take it as properties. Of that one, and we're gonna also take object keys of right, or for the sake of simplicity, let key of object keys, or maybe we can just use let key in left if right key does not equal to left key, then we just return false, right? So that should be more than enough. Okay, so let's do it like that. Object get on property names should be better than. And if one key doesn't equal another, then we return false, and otherwise we just return true. And here we're just gonna compare it. So compare marker values, stored metadata, markers to the actual markers we received. Okay, that's good. Now it still fails because it should be not equals. Okay, now both tests pass and our functionality kind of works. However, I want to add a couple of more tests. I want to add a test should, oh wait a second, where is it? Should invalidate. Yeah, I want to add more test cases here. Should invalidate, cache retrieval if markers count change. So this is very important. Let's say first we get only 2 markers. However, on the second call we'll receive marker 1 equals 1 as well. So we should see, for instance, that here we have marker 2 with the same value as the marker 1 and is the same value as the original one. So ideally, like right now, it doesn't work. Let's see if it happens like that. Yeah, so it doesn't work as I expected, so that's why I added this test case. Now I need to go on and implement a better solution for comparison of the marker values, and probably are markers the same, are markers same. Okay, that's good. And now here we're probably gonna have the same thing, but here we're gonna take a look at get on properties of left do not equal direct equality, all the properties of right, and if they are not equal, then we return false. Okay. Okay, let's see. Does it tell us anything? Okay, store values between instances. Okay, so this kind of thing doesn't work. Now let's say length. Okay. So we just validate that the lengths of both of the property lists do not equal to each other, and now our test case actually works pretty good. But probably we better extract it as a variable, replace all two occurrences, and we'll call it left properties. And here we're gonna have also add as right properties. Okay, so that looks about right. So this should be enough to fulfill this test case. And this one, actually we don't need this test case, it just doesn't make any sense to write a test like that. We better should test that it separates, yeah, it should scope all data with own prefixes. With supplied prefixes. So what it's gonna do, it's just gonna take our standard write storage, and we're gonna create const another storage, cache storage with another prefix. Okay, so that sounds right. Cache one. However, here it's going to be another cache. Okay, that's good. And here in another storage, we're gonna save some data into section 2 with some marker to value 100. Okay, and the data is gonna be another storage, data. Okay, so that's it. So it saves the data, and now we're gonna expect that read storage by loading this section 2 with marker 2 of 100. That's this one. Oh, I completely forgot to switch to a view with the code base. Sorry, viewers. It just bad on my side to not do it properly. So let's see. We have read storage load section to marker 100. That's good. And no one even noticed. Okay, so I wrote a test already for that, and I modified a bunch of code over there. Yeah, sorry. So what we're gonna write an expectation here for that it's equals to undefined. So this is what's the expected value, and let's run a test case, and of course it fails because right now we don't store prefix, we don't add prefix anywhere in a storage. Okay, so let's see. So now I see how I can improve it a little bit. So I can create a new function here, and I will call it storage factory. It's gonna receive prefix as an argument, and internally this one is gonna have browser storage behind the scenes, and it's gonna return back set item yeah, so it's gonna set an item with key and value, and it's gonna get item with key. Okay, that's fine, and we're just gonna return back as browser storage. So here it's gonna use prefix plus key and then value. The same thing is gonna happen for get item from the browser storage. It's just gonna retrieve the value with the prefix. So we're just gonna return back, and that's all. what we need to have. So those values are set, and yeah, so I'm gonna set the stuff here, and yeah, here we are. I think prefix is set here. So after this functionality implementation, probably that's where I'm gonna finish today's stream. So let's see. We have storage factory, and here I want to replace this const browser storage with storage factory of prefix values applied into the function, and in such a way we kind of solve the problem without changing all of this code. We just encapsulated the prefixes over there. So cannot read property markers of null. Okay, this is interesting. So we have something interesting. So JSON parse is actually for a null value as an input, it returns you back a null value, so, or the undefined value. So okay, what we can do here, we could probably create a simple test case for that, and we'll call this test case. It should return undefined value if section is not stored in cache. So we wanna isolate this bug we found during the execution of another test, and we want to have a separate test case for it in order to be able to regress much more easier in the future and pinpoint the actual problem. So we're gonna expect that read storage load of section with, let's say, section 3 with marker 3 equal to 1. We expect that this one equals undefined. So now it should be 2 tests that are failing, yeah, because the property is not set in both of them. So now we can just do something here as well, right? So let's say we have the stored metadata, then we have browser storage, yeah. So if stored metadata type of does not equal to object, return false. Oh, sorry, undefined. So this is what we should return back. Okay. Is null an object? That's funny. Okay. So if not object has own property markers, right? So if it doesn't have any markers, if it doesn't have any markers itself, oh, can I pass it like that? Okay, let's see. Probably store metadata if it doesn't have markers as a known property. Yeah, I cannot read it as own property because it's not an object. And can we check if it's is okay. So we probably then just have to evaluate it like that. If it doesn't work like that, that would be funny. Okay, so it works like that. Okay, so now I'm done for today. Tomorrow evening I'm gonna continue again with the same project, and tomorrow I'm gonna continue on working on resolver. Here I'm gonna continue on building this cached functionality, so tune in tomorrow to see how it plays out, and I hope tomorrow we're gonna have a little bit closer state of the project. So before all you go, I'm just gonna run yarn test. Let's see, we have one test actually failing. Yeah, so we still have a failing test in data resolver. Probably we can quickly implement it by just using our new storage, right? So okay, so yeah, what's that schedule load is gonna do, right? It's gonna store first of all value, so it's gonna take a value and we're gonna resolve this value. That's one thing. And another thing here, yeah, because I want to make sure that the test is passing, and here as well we're gonna store it into the cache storage. So where is our cache storage for block itself? So we'll add it as a third argument, cache storage here, and here. Actually, no, not the third argument. What I'm doing, that's stupid. I think it should be initialized somewhere here, and we'll need to specify cache prefix as an argument here, and this cache prefix is gonna be equal to some default data resolver by default if it's not set. Okay, so this is good. Now we can define our const as cache storage equals cache storage itself that we're gonna import here. So we're gonna import cache storage from cache storage, and here inside of the cache storage we're gonna specify cache prefix as an argument for cache storage. Here we are, and here we're gonna save section with the value and with the current cookies, right? So what we can do here, probably we can definitely utilize some of the magic of this method in order to retrieve the cookie values. So what we're gonna do here, actually gonna create read cookies and then cookie names and read cookie method itself, and we're just gonna steal this method, and a result here for reducer gonna be an object, not a boolean value. So here we're gonna return back the result, of course, because it's a reducer, and then here in result cookie read cookie. So that should be fine. And now here we're gonna pass just cookies. And we're just gonna modify here the logic like that. So first here on load we're gonna set cookie values to be equal read cookies, required cookies, right? And then we're gonna pass the cookie values into the required cookies, and then we're gonna specify it here. Okay, so sounds good enough. Now, is it still failing? Not that one, so let's see if we can again run this test. Okay, so cannot access cache storage before initialization. Okay, why? Oh yeah. Let's rename it as storage, because it has a name collision, so it doesn't like it. And read cookie is not a function. Oh yeah, because I didn't specify it over there. Okay. Now it's a proper error message. And here if storage load this section and then cookie values, so we're gonna specify here const cached value. If cached value does not equal to undefined, then we return back promise resolve cached value. So if the value is already available, we just already returning back as a result promise. And now all our tests are passing, so let's run it again from the command line just to make sure that we didn't break anything else. Okay, all the tests are passing. We have 2 more tests to do that we're gonna implement tomorrow. Get status, get add, src, get status, get commit, implement cookie markers, also add cache, add basic cache storage implementation. What else? Implemented simple cookie marker invalidation. Okay, and git push. So the code should be available in the repository you see in the stream description. At least I'm gonna add it to the stream description definitely, because yesterday it was there. Let me do it actually right away. So thank you everyone for joining the stream, and till tomorrow. Have a nice rest of the day. It's 10:30, half past 10 p.m. Over here, so have a good night.